Sorry, I got a visitor and had to pause for a second. Okay, so we get to the place x squared equals 72, and this is where we have x squared equals number. So this is the point where now we can take the square root of both sides. We know what x squared is, we want to find out what x is. So x equals plus or minus, let's see, 72 divides into, is it 36 and 2? And 36 is 6 times 6, so we get x equals plus or minus 6 root 2. Okay, so that was square root method. All right, over here we're going to do completing the square. This one's written in standard form. There's no a value besides 1, so we're ready to go there. Let's start by moving the constant over to the other side. And then remember that when we're completing the square, what we want to do is custom build a factor so that when we multiply it all together, we'll get x squared plus 6x plus something. So let's just to remind ourselves of where this is coming from, let's multiply out x plus 3 times x plus 3. Okay, these two are like terms, so we get x squared plus 6x plus 9. This and this are not equal yet. We're missing a plus 9 over here, so I'm going to add a 9 in and add a 9 there. Now these two plus this, they're all equal to the same thing, right? All that stuff equals the same thing. So we've built a custom factor, x plus 3 squared. 15 plus 9 is 24. Now what we have is a situation with quantity squared equals number. We can solve this by taking the square root of both sides. The square root symbol and the second power cancel each other out, and we're left with x plus 3 equals plus or minus, let's see, 24 divides into 4 and 6. 4 is 2 and 2. 6 is 2 and 3, so that doesn't break down well, but we can do 2 root 6. We have one more step because x is not alone, so we need to subtract 3 from both sides. And I typically write it with the negative 3 in front, plus or minus 2 root 6. You could also write it as plus or minus 2 root 6, and then minus 3 at the end. Okay. And finally, quadratic formula example. So they've written it in standard form. We want to find what A is, and B, and C. And we've practiced these, so we should be pretty good at it by now, just finding these things. So let's use the quadratic formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I don't know where I've placed my calculator. So let's see here. Negative 9 squared, that's 81. Minus 4 times 1 times 21, that's going to be minus 84. So I think we'll get negative 3 for our discriminant. X equals 9 plus or minus the square root of negative 3 all over 2. Now we're going to simplify the radical. The square root of negative 3, we can pull that negative out as an I. So we've got I root 3 all over 2. That takes care of that one. Okay, so the homework assignment is there. Notice that the first two problems, they ask you to solve by factoring. Next two, square root. So they're telling you the method to use on the front side of the page, okay? When you go to the back side of the page, they're telling you to choose the best method, and you want to use each method at least once. I want to talk with you about how I determine what the best method is. So what I would do first is to look through and find the method that, or the, I think looking for square root method first is nice, because remember that's the one that's missing the linear term. And so that should be pretty easy to see at a glance. So let's check through each one and see if it's missing a linear term. There's the linear term for 9. There are 2 linear terms for 10. Aha, on number 11, no linear term. So this would be a great one to use the square root method on. Remember, our goal is to get it to look like x squared equals number, and then we can solve it. Number 12 has a linear term, so it's no good for square root method. 13 has a linear term. 14, 15, here we go. No linear term on this one either, so square root method could be a good candidate there. We want it to be x squared equals number, take square root of both sides and we're set, and a linear term on that one. The next thing I would look for, so you know you can solve 11 and 15 using the square root method. The next method I would check for is factoring if possible. So to decide if we want to factor or what we can factor, we would probably want to write the equation in standard form. So I'm going to subtract 3x from both sides, subtract 10 from both sides. Now I don't have any like terms to subtract from over here, so it's going to end up being 2x squared minus 3x minus 10 equals 0. Okay, we have a, b, and c here. A times c, that's negative 20. Can I find two numbers to multiply together to give me negative 20 and add them to get negative 3? Well, 1 and negative 20 multiply to give negative 20, but if I add those, I get negative 19. 2 and negative 10, I would add and get negative 8. Can't divide by 3 and get an integer, but 4 and negative 5, that would give me negative 1. I think this one is not going to work for factoring. Okay, so next I want to see, is it a good candidate for completing the square? To decide if it's a good one for completing the square, remember that we want a to be 1. So I would divide every single term by 2. And then I want to look at my b value. If I take that and divide by 2, negative 3 halves, do I get an even number? And the answer is no. In fact, I get a decimal right off the bat. So I wouldn't solve this by completing the square, nor factoring. Instead, this would be a last result one. I think that I would use quadratic formula here. Let's look at number 10. Okay, to get this into standard form, I would subtract 2x from both sides. So here we have x squared plus 8x equals 0. Notice that our constant term is missing, so c is 0 for this problem. As I look at factoring, if I take a times c, that would be 1 times 0, which is 0. B value is 8. Now, as I look at multiplying to get 0, the only way I can multiply two numbers and get 0 is if one of those numbers is 0. Now, when I'm adding, I want to add these two numbers and get 8, so I think the other one has to be 8. All right, so as I list the factors, it could look like x plus 8 and x plus 0, and then I'll let you go ahead and solve it from there. One other thing I want to mention is we could have, from this point, just found the greatest common factor, which was x. Then we have the factors x times x plus 8. We would see this answer pretty easily. Sometimes students don't see that answer quite as easily, but remember that we're looking for what can we multiply this by to get 0 there, or to make the whole thing equal 0. So if that one is 0, then it would work. Okay. 12. Okay, so if I move the 7 over to the other side, then a times c, that would be 7, and b would be 2. Since 7 is prime, this one doesn't seem like a good candidate for factoring. I don't see how I can use those two numbers to add together and get 2. So what I might do on this one is divide every term by that negative 1, and then look, your b value would still be even. So this could be a good candidate for complete the square. Maybe we'll just write this first step of divide each term by negative 1 to get people started. So complete the square there. I hope this has been helpful in helping you see how to be strategic in choosing the method that's going to be most beneficial for you.